Okay, in this video I'm going to continue on with my tutorials on thermodynamics and statistical mechanics. So this is number 29, and I'm going to discuss how we can predict the heat capacity of a body. The previous videos to this are as follows. Number 28 I discussed the entropy versus energy graphs. Number 27 I discussed the meaning of temperature. So we saw that temperature is the inverse of del S del U. And in number 26 I discussed entropy and introduced it. And in number 25 I discussed the second law of thermodynamics. So basically for the last number of videos what we showed was that temperature is equal to del S del U, well, the inverse of del S del U, a constant number of particles and a constant volume. So really the question is this: if I understand the multiplicity function of a body, how do I get its heat capacity? Is there a way of predicting the heat capacity just knowing the multiplicity function? That's the whole point. So the answer is, of course, yes. Now, in previous videos we discussed the heat capacity. I'm just looking at my videos here, and I see in actual fact that number 6 is where I discussed. So if you want, you can look at video number 6. I discussed the heat capacity, and I showed that the heat capacity at constant volume is equal to del U del T del U del T at constant number of particles, constant number of volume. And for 1 mole we saw the heat capacity at constant pressure is equal to the heat capacity at constant volume plus the molar gas constant. Alright, so how do we get from we'll say here to here, or how do we get from the multiplicity to here? Okay, let's go about doing it. It's actually quite straightforward, and you could probably guess it if you liked. So basically what we do is exactly what I have done in the last number of videos. So well, we need to get the multiplicity. So how do we get the multiplicity? Well, we use quantum mechanics. Okay, because all systems are quantum. So we use some sort of quantum mechanics to get the multiplicity function. So we usually like to get the multiplicity function in terms of the energy, the volume, and the number of particles. So we get it in that particular form. Alright, well, what was the next step? Well, what does multiplicity give you? Well, we don't like dealing with multiplicity. We like to deal with entropy, which is k times the natural logarithm of multiplicity. That's not new. Well then, in the previous videos, we saw, well, we could use S in order to get T, because if we got del S del U, entropy versus energy graph, we got that as 1 over T. Okay? Now, what we can do then is we can rearrange this particular formula. Now we have the formula, we have relating energy, temperature, and entropy. So we rearrange in a biro, of course, that works. So we rearrange for energy. So what we get is energy as a function of temperature, the number of particles, the volume, entropy, whatever. Okay, so we now have energy. Now look, that's the formula. We're after getting energy, and it's as a function of temperature. So it's very easy to get the heat capacity at constant volume. We just get del U del T, holding everything else fixed. Holding, we'll say, N and V fixed. That's equal to C sub V. Alright, so that's really what I've been doing the last number of videos. So the whole point is, to get the heat capacity at constant volume, you get the multiplicity first, then you get the entropy, then you get the temperature, and then you rearrange for energy and get the derivative with respect to temperature. It's pretty straightforward. The hardest part by far is up here, getting the multiplicity function. That's not an easy thing to do, but as we can see, we've done those steps in the last number of videos, and it's very straightforward. So, thanks for watching. Please pass it on to your friends, subscribe to my channel, and if you're in a good mood, you might also click on an ad. Thank you.